Welcome back. Welcome to section 3.1 of college algebra. Today we're going to be talking about functions and function notation, which is the first time we're finally going to get to this f of x, or this input-output relationship that we've been seeing. So let's go ahead and get started with section 3.1 from college algebra. All right, so functions and function notations take all of this equation stuff that we've been writing and apply it into specific numbers and instances where you have an input that's a specific number, you input it into the function, and you receive an output. Whether the same or different, it takes a number or input and turns it into another number or output. You can see that in these graphs right here. We've got 3 different graphs showing function, a special type of function, and then a not function. So here we have the first type of graph, input-output diagram, where we've got P turns into M. Say that's 2 and 3. 2 turns into 3. P turns into M, Q turns into N, and R turns into N. Now the only thing for this to be a function that needs to be true is that an input needs to turn into a output. It doesn't have to be a unique output for it to be a function, but it needs to turn into one output. We'll get to that in a second, but this is a special type of function where every input turns into exactly one unique output. That's a really specific thing that we'll talk about later on in the course and in this section. That's a one-to-one function. So this one's just a function. Call it f of x, call it whatever you want to call it, some random function. Second one, special type of function, a one-to-one function, where every input turns into exactly one unique output. And this third one is not a function. And the best way I have to explain a not function is, let's say I'm giving out tests at the end of a class, and I give every student tests, and I ask the question, is it possible for 2 people to make 100? So let's say Jimmy and John both make 100. Is that a totally okay thing to say? Well, yeah, that's totally fine. If everybody did really good, maybe everybody gets 100. So the function still exists that your name tells me your grade. If I take Jimmy, I can look at his paper and get a grade. Now it's possible for everybody, now it would be really mean if I said, okay, only 100's going out, and only 199 and 198 and 197, and that's how this class is going to work. That would be a one-to-one function, and that would not be a really nice way to do it. And then the third case would be I give Jimmy's paper back, and Jimmy's paper says 50 and 100 at the top. And then Jimmy comes to me and says, well, which one is it? Did I get a 50 or did I get 100? And I say, both. That's not a function. I can't look at Jimmy's paper. I can't look at Jimmy's name in my grade book and say what grade he got. So every input needs to give you one output. Is the definition of a function. That's the grade thing, I think, is a really good way. The name turns into a grade. A really good way to visualize functions when you're trying to decide, is it a function, is it one-to-one, or is it not a function at all? So here we go. I'm going to do this really quickly, and then we're going to get to some applications. The really quick example is baseball. We've got these baseball players, and we've got their ranks. And the question I ask you is, if I give you a rank, can you give me a name? So I'm not even going to look over. If I say, who is the best baseball player in the world? Babe Ruth. Who is the second best baseball in the world? Mays, Cobb, Johnson, Aaron. We've got, for every rank, you can tell me the baseball player. So yes, it's a function. But then what if we go backwards? For the baseball player, can you tell me the rank? And if you look at the graph, for every baseball player, you can tell me the rank. So yes, it's a function both ways, which means, here, wait, I'm gonna do this in a different color to kind of show what we're talking about. I'm gonna do this in green. Yes, it's also a function this way. That means that rank is a function of player name, and player name is a function of rank. You could call that f of rank and f of player. You could do whatever, call it what you want to call it, but both are functions. All right, let's keep going. I'm going to skip down to some practical applications because it's a little namey and a little less specific. So real practically, what happens when I give you a function and I say, this is a function, you solve it? Okay, so I've got you input m because it's inside of these parentheses. M is your input, and your output is whatever you get with the math that we did last week in chapter 2. So I'm going to say I'm going to input everywhere I see an m of 5. All right, well, the left side was easy. Nothing happens. It's just g of 5. The right side's going to take some math, but not too much math, and we're going to get the square root of 1, which is just 1. Because they'd already written the square root, we're going to go ahead and assume that they gave us the correct sign in front, and that is a plus sign because they didn't write a minus. I know that I get a lot of questions on that, so I like repeating it. if they give you the square root, if the problem writes the square root and prints it from the printer or from the PDF online, then they've chosen the sign for you. But if you write the square root for the first time, you introduce a square root to undo a square, then we have to be really careful to add our plus and our minus because we introduced the square root and we didn't know what we were picking. So that's a reason why I'm in class will have students raise their hand and say, oh, is it plus or is it minus that one? And I'll say, well, because it's already pre-written and pre-printed, we go with the sign that they gave us. So we've got 1 as our answer, so g of 5 equals 1. Not too bad. What happens when they flip-flop it on us? What happens when they give us the number on the outside but not the number on the inside? They give us the output, not the input. Well, they've told us that h of p is 3, and look, we've got this h of p right here. Well, they told us what that was. That's 3. They didn't tell us what p was, and that's where we're going to apply our skills from last class to solve. Pause it right now if you want to go and try to solve it on your own because you should know quadratics. You practiced them all week. You did a good job in chapter 2, and you have the skills to do this. If you're just now unpausing it, that's great. I'm glad you tried it on your own. I'm going to move the 3 over. I'm going to set it equal to 0. I'm going to factor it into a plus 3 and a minus 1. That works. And then I'm going to solve for my 2 inputs, which are p equals negative 3 and p equals 1. Say, am I allowed to have 2 inputs? Absolutely, I'm allowed to have 2 inputs. If you have any familiarity with the parabola, right? Are you allowed to have 2 spots at 3, 2 different x values or p values at 3? Absolutely, you can have 2 x values. What you couldn't have is the opposite. You couldn't plug in a 3 and get 2 different things. All right, let's keep going. I'm going to skip ahead a little bit so we can kind of move through this and get to the table. We'll get to table, graph, and input, and that's kind of the 3 main functions. All right, so we're looking at a table now, and I'm looking at input of 3. So this is the green one. If I input 3, I output 7. And you just follow the table just like that. Make sure you read the things on the left. Make sure you read which column is which. Maybe they try to mix it up and put them upside down so you go with your habit and not with checking. Make sure you check your input and your output. All right, let's do all these. 6, we got the red one. The red one is g of n equals 6. So where is g of n 6? It's right there, and we're going backwards to look for our input, where n equals 4. N was the input, right? Oh, let's label. Input, output. It's a good idea to do when you're working with functions. And if you input 1, what do you output? Do this one in orange. If you input 1, you output 8. Not too crazy. Graphs are going to work the exact same way. If you input something, it's on the x-axis. And if you output something, it's on the y-axis. So we've got our input, and we've got our output. And we do the exact same method we just did. So f of 2, if we input 2 on the x-axis, that's right here, we go up until we find that blue line, and we say, what did we output? If we input 2 on the x-axis, that red line takes us, and we output 1. And then vice versa. If we output 4, what did they input? We've got 2 different things that they could have input. Oh, sorry if that audio was a little low. We've got 2 different things that they could have input, right? They could have input a negative 1, or they could have input a 3. And both are fine. X equals 3 and x equals negative 1 are both fine inputs. And then we're going to do it again for output of 1. I've got 2 different spots. I've got x is 0 and I've got x is 2. And both of those could have been an output of 1. Okay. I'm going to skip forward to this graphing. Oh wait, no. We need to do this one-to-one functions. So we already talked about it a little bit. One-to-one means you have exactly 1 input value. And they didn't use the word unique here, though I like it. Each output corresponds to exactly 1. This word exactly is doing the most work there, where they're saying each value on the inputs corresponds to exactly 1 output, not 2. And it doesn't, there aren't 2 corresponding to the exact same output value, right? So what that basically means on that function, if we've got A, B, C, 1, 2, 3, and we've got a function mapping, a mapping diagram going that way, they're always going to have straight lines. You're never going to have a mapping diagram where 1 input goes to 2 different outputs. So let us move forward to this vertical line test and see if we can't determine functions and determine one-to-oneness. All right. So the vertical line test, is a test for functionality, or a test whether it's a function or not. And all we do, it's a little easier to do on mine paper than yours, but you can do it with your pen, and you can run your pen across the paper. I like to draw a straight up and down line, click on it, and just drag it across and say, does that red line ever hit that function twice? And if it hits the function twice at the exact same time, then it's not a function. I don't see a spot where that happens, so we give this a check mark. It's a function. I'm just going to drag that same red line across all these functions and say, function or not. Does it ever hit that blue line twice? Nope. So that one's also a function. Let's keep going. Does it ever hit, oh, right away. Does it ever hit that circle twice? It does, right there and right there. So we're going to say not a function. Last but not least, does it ever hit that blue line twice at the same time? It does not, so it's a function. It's actually a pretty common absolute value function. We got ourselves a cubic, we got ourselves a linear, we got ourselves a circle, which is a different type of thing, and we got ourselves a absolute value function. Awesome. So if there's a vertical line test, there's probably a horizontal line test, and for that we're going to do the exact same test but with the horizontal line. And what a horizontal line test determines is if it's one-to-one or not. If that function is invertible or one-to-one, or for every input and output there's exactly one input or output. So I'm going to draw the same line but horizontal, and I'm going to go up and I'm going to say, oh, immediately that fails. 1, 2, 3. Fails 3 times in a row, not one-to-one. Still a function, just not one-to-one. Let's do it again. Move this red line over. Hey, look at that. That one passes. A linear function passes. So check, 1-to-1. Move it over, do it again. Boop, immediately fails. Fails in almost every spot except for 2. So this one is not one-to-one. And then we've got one more test where boop, it fails. And so this is not one-to-one. So we only had we only had a single one-to-one function in that try it. But we did have 3 functions. If those are the same functions in both of those. Awesome. So, and last but not least, something really important, and I can't stress this enough. Every year I stress this, and somehow it becomes the least important page, where I think this is the most important page on the chapter, or on the section. This page is functions that you need to know and be familiar with. If you scroll through this page, when you see we talked about this Hoy-Vux thing with the constant function, we've talked about that in the horizontal zero slope y equals form. Here they have it as f of x equals form, taking the place of the y. We've got the identity function, which is a special linear function that occurs where the x equals the y value. We've got absolute values, quadratics, cubics, reciprocals, reciprocal squared, square root, cubic root. We've got types of functions that you need to know. Now there's other types of functions in this class that we'll work through, but these 9 functions are the basis of everything we'll do for even a long time in math, not just in college algebra, but in pre-cal and cal 1. These 9 functions form the basis of almost everything we do. And so it's really important that when you see a shape, you recognize the shape. So for instance, if I was going through the last thing, even though they didn't ask me about them, when I see this shape, I think that's most likely cubic. I see 2 turning points. I see a shape that looks like an S, like cubic function. Linear function, circular function, not a function, circle, and absolute value function. So I would implore you to become familiar with this page. Treat this page as the most important page of this unit, not the least. Even though there's not a problem on it, it is a way to familiarize yourself with the functions that we'll be using in this class. So thank you for watching so far. Remember, there's plenty of exercises in the textbook if you need extra practice, as well as the homework that will be due after this video. And if you need to go back and watch some videos to get more familiar with linear functions or quadratic functions, you're more than welcome to do that as you prepare for this chapter 3, which is going to get into all types of functions. So thank you for watching, and I hope you have a great day.